Okay, guys, chapter 1, section 2b is solving rational equations. What did I tell you yesterday? What's the hardest part about solving these equations? The first step, and signs, good. But the first step, because you'll see these rational equations, once we get past the first step, it then becomes a linear equation that we did yesterday. On your quiz and on your test, it will say solve by factoring, solve the rational equation, solve by completing the square, solve by using the quadratic formula. If it explicitly tells you how to solve, that's the way you have to demonstrate how to solve. Once we get past this, you have anything in chapter 2 that says solve, you do whatever you want. You do what works best for you. Some of you work better with completing the square. Some of you work better with quadratic formula. But this chapter is making sure that we understand all the different types and ways that we can solve. So your quiz is just going to be solving equations. It's just going to be a bunch of different kinds. So that's why the practice is so important. Today we're talking about rational. What I tell you guys was super duper grown-up way to say what? Fractions. Good, okay. And when we're adding and subtracting fractions, what do we have to get? Common denominator. We've already done that. And what can your denominator not be? Cannot be 0. So those are all things we have to remember. We're going to get a common denominator. Then once you do that, you don't even have to worry about the denominator anymore. I'll show you. And then we have to plug our answers back in to make sure that our denominator does not become 0. So it says eliminate fractions by multiplying by the least common denominator, which we kind of did yesterday, and we also have done it previous things we were adding and subtracting. And then you have to check your answers for extraneous solutions. Those are ones that when you plug them back in, they do not make the equation true. You're going to have to do that from now on when we do factoring, square roots, that sort of thing, because you'll get x values that when you plug it in, it makes the equations untrue. So let's look at this. The first 3 are super basic. I'm going to show you like we did yesterday, and then I'm going to just write it a little differently after I do the first one. What we did yesterday was we said, okay, I have 3 fractions, so I want to get what? I want to get a common denominator. I'm going to get rid of the denominator. That's how I'm going to think about it. I'm going to get rid of it. So what would I multiply all 3 pieces of this equation, both the left-hand side and the right-hand side by, so that my denominator is gone? 12. Okay, I agree. So what? Because 3 times 4 is 12. So when I multiply, 12x divided by 3 gives me 4x, good. Then I multiply 12 times 3 divided by 4. 9x, good. Equals, what's 12 times 2? 24. Now, guys, we have eliminated the denominator. So we combine like terms. 13x equals 24. So what does x equal? 24 over 13. Now, is that a beautifully easy thing to plug back in and check? No. What I need you guys to check for, what I need you to focus on, is the value that you get for x. If you plug it back into the equation, will a denominator become 0? Is that the case here? If I plug 24 over 13, is that in any way going to make any of my denominators 0? No. So then we're good to go. All right, so let's do the next one. I'm going to do the next one the exact same way, and I'm going to show you a different way to do it that might be easier for you. It may not be. But looking at this whole equation, I want to get rid of my denominator. So what is my common denominator between 5, 1, and 3? Perfect, 15. So my first fraction, 30 times 2 divided by 5 gives me, perfect, 6x, plus 15 times 5, 75x, equals 15 times 4 divided by 3, 20. Do you notice, guys, that first step of eliminating the denominator, then I have just a regular basic linear equation. Combine like terms, so 81x equals 20. Divide both sides by 81, and x equals what? 20 over 81. Now, what do I need to look for? I need to make sure that when I plug my x back in, my denominator does not become 0. So we're good to go. Everybody good? Okay, another way that you can set this up, we're going to be doing the exact same thing, but another way that you can set this up that I think might be a little easier once we get into variables in the denominator. Okay, do you guys see we have fractions on both sides? Okay, I have all different denominators. So what's my common denominator going to be between 2, 5, 1, and 10? 10. I like to just put it over here to the side. I'm multiplying it through, I know, but in my mind, I'm just going to put it over here to the side. So I look at my first fraction. 5 times what gives me 10? 2. If I multiply the bottom by 2, then I have to multiply the top by 2, correct? So I have 2x. So I look at my second fraction. It has a 2. What do I multiply top and bottom by? 5. Good. So minus 5x equals, what do I multiply 1 by? 10. So multiply the top by 10, and I get 30. And then what about the last fraction? Keep it. Just stays plus 3x. Stop. So what we just did was the exact, I multiplied everything by 10. But to me, it's a little easier once we get to a little more complicated denominators to put it over to the side and kind of see what does my fraction have, what does it need. But once we get to this point, everybody in here could solve this very easily. Combine like terms. I have negative 3x equals 30 plus 3x. Please don't make a mistake and go, oh, it's no solution. The 3's are going to cancel out. Do the 3's cancel out? No, guys. Go ahead and finish the problem. I have negative 3x on both sides, so negative 6x equals 30. Divide both sides by negative 6, and what does x equal? Negative 5. Is there anywhere in this equation that if I plug negative 5 in, my denominator becomes 0? No. Perfect. Move along. All right, what's your common denominator here, guys, between x and 1? Just x. If you want to put an x out on the front and multiply all the way through, you can. I'm just going to do it this way. I like it this way better. So I look at my first fraction. What do I have to multiply the denominator by? Just 1, okay? So I'm going to write 15. Minus my 4. What do I have to multiply the denominator by? X, which you... Uh-huh.
Why are we not multiplied by... Oh, okay, never mind.
I'm doing the exact same thing, just put it on the side. Yeah. Because you're making an equivalency throughout. So like if we were going to go like this with x all the way through, right? This would cancel here, correct? Then I would have 4x, then this would cancel here, and then I would have 3x, just like we did on all these problems here. Once you get the denominators to be quote unquote gone, you get a common denominator. When the left-hand side denominator is the same as the right, you can cross them off because it's equivalent. It's the same. So I just like to write it a little differently. All right, so look at my next one. My 4, what does it need? It needs an x, good. So I have minus 4x equals, what about 6? Just leave it, good. And then what about the 3? It needs an x. So again, guys, what I said yesterday, the first step is the hardest because once you kind of go through and you're like, okay, I've got the least common denominator, it's equivalent on both sides, then you don't have to worry about the denominators. Now you're solving a linear equation. Yeah?
So if x equals 0, is it no solution?
Correct. We're going to come to those in a second, but good. So I'm going to subtract 3x from both sides and add, just kidding, subtract 15. What's negative 4 and negative 3x? Negative 7x. What's 6 minus 15? What is it? Negative 9, okay. And then I divide both sides by negative 7. So x equals what? What kind of 9 over 7? Positive. Good. Now, check to see. If you put 9 over 7 here, does that make your denominator 0? No. If I put 9 over 7 here, does that make your denominator 0? No. So then you're good to go. You'll see. Hang on. Please. Okay, a lot of you had this question yesterday on WebAssign, and you came up to me and you're like, I don't understand. We're just relax for a second. Now, 2 ways you can look at this. Yeah. Yes. Why can you just cross multiply? Good, Luna. It's 1 fraction equal to 1 fraction. In number 7, it's not just 1 fraction on one side and 1 on the other. In number 5, you can just cross multiply. If you don't like that, if you're like, wait, how do I know? I never know when to do what. It's fine. What would a common denominator be between 2 and 5x plus 6? 2 times 5x plus 6, right? So my first fraction has the 5x plus 6. What's it missing? The 2. My second fraction has the 2. What's it missing? The 5x plus 6. It's the same thing as just cross multiplying. If you were to cross multiply, you would have right here 1 times 5x plus 6 equals 2 times 10x plus 3. Exact same thing. But last period, people are like, I never know when I can cross multiply or not. Then fine, don't worry about it. If you recognize it's a fraction equal to a fraction, then perfect. So with that first step out of the way, this just becomes a basic linear equation. I'm going to subtract 20x from both sides. Subtract 6. And I get negative 15x equals 0. This blew some of your all's minds yesterday. You're like, it's no solution. Guys, when is it no solution? When it's a number equal to another number. 0 equals 7.
I have 15x.
You just move it the other way? I just always move things to the left.
Yeah, oh, okay.
When is it all real numbers?
When it's the same thing on each side.
Same thing on each side. It'd be 0 equals 0. This is neither the case, guys. Can you solve this equation? Yes, divide both sides by negative 15. What's x equal? 0. Is that an okay answer? Yes, you just cannot have 0 in the denominator. Think about this. If I plug 0 in here and 0 here, does 3/6 equal 1/2? Yes, so it makes your equation true. Yeah.
How did you get rid of the denominator on this?
You can either cross multiply, or right here, I wrote down what the common denominator would be. So then I figured out, okay, for this one, it has the 5x plus 6. It's missing the 2, so I multiply by 2. And for this one, it has the 2. It's missing the 5x plus 6, so I multiply the top by 5x plus 6.
So, I got a weird answer.
All right, let's move along to number 6. Okay, this is where it gets a little more tricky. You can't just go like, you can, but it makes it a little more difficult to get rid of the denominators. That's why I showed you the other way that I was doing it. Guys, first of all, we need to factor first. Some of you made silly mistakes on your test where, like, if you're trying to get the same denominator, you just put a -5 on the first part. You can't do that. There's two different terms here. One term is x, one is x minus 5. So what is a common denominator between those two things? X times x minus 5. Don't multiply them together. You want to keep everything in its factored form. So now that we've identified what our common denominator is, my first fraction has the x. What's it missing? X minus 5. Perfect. My second fraction has the x minus 5. What's it missing? The x. 0. Doesn't have either of them, does it? So what does it need? X times x minus 5. Now that you've made equivalency, the denominator doesn't matter anymore. That's why I say just put it off to the side and then rewrite your linear equation. So this is 1 times x minus 5 plus 2 times x equals, what's 0 times x minus 5? 0.
Can't you just cross multiply these?
No, because there's a plus sign here. If it was just one fraction, you could.
Wait, when your answer just keep x equals 0.
No, let's finish it. We have to combine like terms here. So I have x minus 5 plus 2x equals 0. What's like terms? X and 2x gives me, perfect, minus 5 equals 0. 3x equals what? 5. So what's x equal? 5 over 3. Perfect. Now what do I have to make sure of? Hold on, Luke. If I put 5/3 here, guys, is that going to be 0? No. If I put 5/3 here, 5/3 minus 5, is that going to be 0? No, so you're good to go. Luke, question? Sure. Yes, sir.
So as soon as the denominators are the same, you just take them out?
Yep. All right, let's, yeah.
I cross multiplied and I got the same thing too.
Only because it was a 0 on the left-hand side. That's the only reason why. Because, in a sense, if you moved the 2 over x minus 5 to the other side, it would just become negative, and then you can cross multiply. But that's only because it was equal to 0, yeah. All right, guys, let's factor first. Always factor first. I have 2x plus 1, 2x minus 1, and 1. So what's my common denominator between all three of those? 2x plus 1 and 2x minus 1. All right, perfect. So my first fraction has the 2x plus 1. What's it missing? 2x minus 1. Perfect. My second fraction has the 2x minus 1. What's it missing? 2x plus 1. My third fraction doesn't have anything. So what do I have to multiply by? 2x plus 1, 2x minus 1. Great. So now your denominator's gone. You've made it equivalent on the left-hand side, the right-hand side, so you don't worry about it. So just rewrite your linear equation. 2 times x minus 1 minus 8x times 2x plus 1 equals negative 4 times 2x minus 1 times 2x plus 1. A linear equation that everybody in here can handle. You just got to take it one step at a time. Let's distribute the 7. So 14x minus 7. What am I distributing here? Negative 8x, right? So I have negative 16x squared minus 8x. Everybody with me? All right, equals, I'm going to go ahead and FOIL this. What is this going to become? 2x minus 1 and 2x plus 1. Say it again. 4x squared minus 1. Good, because when you multiply, it's the same terms, different signs, it's going to cancel out. Yes, ma'am. Okay. I multiplied 2x times 2x, I got 4x squared. 2x and 1 is plus 2x. Negative 1 and 2x is minus 2x. I'm foiling these two right here. And then this is minus 1, and then I combine like terms. I mean, you could multiply the negative 4 in first, but it just makes it messier. All right, so I'm still going to distribute here. I have negative 16x squared plus 4 on the right-hand side. I'm going to rewrite the left-hand side, negative 16x squared. What about 14 and negative 8? Plus 6x, good. Minus 7. Now we want letters. So now I'm going to add 16x squared to both sides. What happens to my 16x squareds? They cancel, good. So now I'm going to add 7. So I have my x's on one side and my numbers on the other. So 6x equals 11. Divide both sides by 6. And what does x equal? 11 over 6. Now, before you guys pat yourself on the back and say, oh my goodness, thank gosh, I got this one done. What do I have to make sure does not happen? That when I plug x back into my denominator, it doesn't become 0. If I put 11x times 2 plus 1, that's not 0. 11x times 2 minus 1, not going to be 0. So you're okay. And you guys are sitting there going, why does she keep asking us to do that? Because it's going to happen. I just want to show you. From now on, when you solve, whether we're solving rationals, solving by square roots, solving by factoring, when you plug back in, sometimes the solutions you get may not satisfy the equation. Yes, ma'am. You'll see. Luna, question?
Why do we only do the 11 times 2x?
What do you mean?
Instead of like 11 over 6?
I said 11 over 6.
Oh, okay.
If you multiply 11 over 6 by 2 and subtract or add 1, that's not going to be 0.
Okay, yeah.
All right, so let's look at number 8. Here's a mistake that some of you guys made. You did not factor first. You have to factor first when you have rationals, anytime. So what am I talking about? X squared minus 4. What does that become? X plus 2 and x minus 2, okay? Now look and say, oh, okay, what's my common denominator going to be for all three of these? X plus 2 and x minus 2, okay? So in your mind, you want x plus 2. Oh, yeah, these colors. And x minus 2. So my first fraction has the x minus 2. What is it missing? X plus 2, okay? My second fraction has the x plus 2. What is it missing? X minus 2. My third fraction has what? It's got a both, right? So my denominators are now equivalent on either side. I can forget about them. So I write my linear equation. 1 times x plus 2 equals 3 times x minus 2 minus 6x. Notice, guys, once you get past that first step, this becomes a linear equation that we did yesterday. It's the first step that you have to get past. We factor first, get a common denominator, multiply through. So I have x plus 2 equals 3x minus 6 minus 6x. Yeah? Okay, on the right-hand side, what can I combine? Okay. So I have negative 6 minus 3x. Or you can write it negative 3x minus 6, doesn't matter. So let's move numbers to one side and letters to the other. So I'm going to add 3x plus 3x minus 2 minus 2. And I get 4x equals negative 8. So what does x equal? Okay, x equals negative 2. And you guys are like, oh, thank goodness, I got a nice pretty number. It's so easy. What happens when I plug negative 2 in here? What's negative 2 minus 2? Negative 4. Okay, we're good. What happens when I plug negative 2 in here? My denominator becomes 0. Therefore, this is an extraneous solution. You don't have to write the word extraneous, but you need to cross it off, make sure I understand that you understand, and then write no solution. When we get to later lessons in this chapter, like when we do quadratics, you might get 2 solutions and you plug them in and they both work. Great. You might get 2 solutions where you plug them in and only one works. So you got to cross that one off that doesn't work and keep the other one. You might plug them in and none of them work. So you just have to check to make sure it satisfies the equation. Yeah.
So in this case, so the one that's 3 over x plus 2, it would put 0 in the denominator.
As soon as any of the denominators become 0, it's no solution. Yep. All right, last few. You guys are doing great. All right, let's look. What's my common denominator between x minus 4 and 1? X minus 4. I wish all of them were this easy, right? So my first fraction, do I need to do anything? Nope, 3x equals my second fraction. What do I need to multiply by? X minus 4. Good, so 5 times x minus 4. And my last fraction, what do I need to multiply by? Nothing. So I have 3x equals 5x minus 20 plus 12. What can I combine on the right-hand side? 20 and 12, negative 20 and 12, which is? What is it? Be confident in yourself, please. 98, let's go. What's negative 20 plus 12? Negative 8. So now I'm going to subtract 5x from both sides, right? So negative 2x equals negative 8. So x equals 4. What happens when I plug 4 right here, guys? It becomes what? 0. So then I cross this out. It's extraneous. And we write no solution. Does anybody have any questions about the no solution ones? That's why you have to check. Now you guys understand why I kept saying the same thing. Dylan, do you have a question, honey? You good? Okay. All right, let's look at the next one. How nice. They already factored it for you. What's your common denominator between x minus 1 and x plus 3? Oh, x minus 1 and x plus 3. Perfect. So do I need to do anything to 12? No, I'm just going to rewrite it. What about my 3 fraction? What does it need? X plus 3. Perfect. What does my 2 need? An x minus 1. Good job. So I have 3 times x plus 3 plus 2 times x minus 1. So let's distribute 3x plus 6 plus 2x minus 2. What happens with 3x and 2x? Say it again.
3x plus 9. Yeah.
All right, this is a 9. Thank you. Do you guys ever have teachers tell you that sometimes they make mistakes to see if you're paying attention? I don't do that. I just make a mistake because I'm trying to go too fast. What's 3x plus 2x? Add. There you go, 5x. And then what's 9 minus 2? Perfect. Subtract 7 from both sides. So 5 equals 5x. Divide both sides by 5. So x equals 5. What is wrong with me? X equals 1. Valid or no? Why? What happens when I put 1 in for x minus 1? It becomes 0, so we cross it off and we put no solution. Now, I know as I'm going through this, you guys are like, oh, this is so easy. All right, go home tonight after dinner, before you get on your social media, and pull up some of these problems and try to do them on your own, if you can. Or sit down and say, hey, Mom, I know you guys learned like cool stuff in biology and all that, and you tell your parents about it. Sit down and say, do you want to see this really awesome thing I can do? I can solve rational equations. And then explain it to your mom and dad. And if you can do that, then you know what you're doing. I know it's easier when I guide you. So that's why it's so important, the extra practice. 2 more. Before I just start trying to find a common denominator, what do I need to do first? Factor. What are the factors of -6 that multiply to give me -6 but add to give me 1? Plus 3 minus 2. What's 3 times -2? -6. What's 3 minus 2? 1? We're good. No worries. All right, what's my common denominator between x plus 3 and x minus 2? X plus 3 and the x minus 2. Okay, perfect. So my first fraction needs x plus 3. Good. My second fraction needs x minus 2. My third fraction needs nothing. So you have x plus 3 plus 3 times x minus 2 equals 4. Once we get past that first step, guys, this is a no-brainer. I could give you guys 10 of these to do in 5 minutes and everybody get them all right. It's that first step. So we're going to distribute x plus 3 plus 3x minus 6 equals 4. What can I combine? X and 3x gives me 4x. What about 3 and -6? Minus 3 equals 4. Okay. Add 3 to both sides. 4x equals 7. Divide by 4. X equals what? 7 over 4. If I plug 7 over 4 in here, is 7 fourths minus 2 going to be 0? No. If I plug it in here, is 7 fourths plus 3 going to be 0? No. You're good to go. All right. Make sure you guys are paying attention to everything we do. What is the first thing we need to do? Factor. Factor first. This is x by itself. This is x plus 3. Together, you can't just add a random plus 3 to the first one. What can I factor with the last denominator? X times x plus 3. Good. You have to make sure everything is factored first. Now, once we've done that, guys, what's the common denominator between x and x plus 3? Oh, x times x plus 3. Perfect. So my first fraction has the x. What's it missing? X plus 3. My second has the x plus 3. What's it missing? The x. And my third one has everything it needs, right? So 6 times x plus 3 minus 2x equals 3 times x plus 5. Linear equation. Distribute your 6. 6x plus 18 minus 2x equals 3x plus 15. What can I combine on the left-hand side? 6x and -2, so 4x plus 18 equals 3x plus 15. Subtract 3x from both sides. Subtract 18. And we have x equals -3. Are we happy with that answer? Yeah, I'm happy we got that answer. But what do I need to do with it? Check it. If I plug -3 in here, are we okay? 6 over -3? Sure. What about if I put it here? What's -3 plus 3? 0. Uh-oh. So we cross this off. It's extraneous. And we write no solution. Let me show you guys something real quick. Somebody just had a question on this on WebAssign. It was like... right? And they went to solve, and they told me that the common denominator was 3 times 3x plus 9. Is that true? What should I do first in every single problem we come to? factor. This is really 3 times x plus 3, correct? So what is the common denominator between 3 and x plus 3? 3 times 3x plus 3. You've got to make sure you factor each denominator first. If not, you guys are going to be putting more value into the numerator than you need to, and the simplification is just going to become too hard. So please make sure that you guys are doing that. Now, what I need you to do tonight, right? Play this as you're about to fall asleep, and you'll have wonderful dreams about common denominators. Yeah, you laugh. You need to hear this again, not just go to bed.